Somewhere over the Pacific, a tanker crew watches the horizon, wondering if they'll be the first target on the ground. Aging bombers with wrinkled logbooks wait for another sortie in a world they were never meant to fly in. And while the buff still thunders and the bone still sprints, the clock ticking since the Cold War grows louder tonight. So, here's the question. When the enemy builds a wall of sensors, missiles, and warships from the first island chain to the second, what gets through not a theory, but something that can take off from home soil thread through the densest air defenses and put any target at risk without a refueler sticking its neck out? Enter the B-21 Raider on paper. It's a stealth bomber. In reality, it's a system shift. A penetrating strike aircraft born digital, designed to be upgraded like your phone and built in numbers that matter. And if you think that's just marketing, wait until you see what the second Raider did on its first flight. No external test gear, no training wheels. A sign of its advanced digital twin. We'll also peel back the skin on the parts they tried to hide at rollout the back end. Because to understand stealth in 2025, you start with heat, those exhausts, and the art of making a bomber look cold to a sky full of infrared eyes, old fleet's new threats, and a jet built to flip the script. Stay with me because by the end you'll know why. The Raider isn't just the next bomber, it's the one built for the fight we actually face. The B-21 Raider is more than an upgrade from the B-2 Spirit. It's a response to new global power dynamics. But to understand this, we need to look at the why. Today's U.S. Air Force bomber fleet is old, with airframes aged in decades. The forever flying B-52. Stratofortress, the newest, built in 1962. When Kennedy was president, that means the newest buff is 63 years old. The B-1 and B-2 are newer, but still long in the tooth. The newest B-1 Lancer delivered in 1988 is 37 years old in 2025. The B-2 Spirit had a complicated delivery. The final B-2 delivered was a rebuilt test airframe, joining the fleet in 2000, ending production. That's over 25 years old, older than most Air Force Academy grads. It's not just an aging fleet driving the need for the B-21. While the B-2 Spirit is still considered the stealthiest aircraft, there are only 19 of them. This small force is a silver bullet for specific situations, like Operation Midnight Hammer earlier this year. Yet with today's complex geopolitics, where a Pacific conflict with a near-peer enemy is increasingly likely, 19 airframes won't cut it. Despite continuous upgrades, the B-52 and B-1 are mainly platforms to launch standoff weapons outside heavily defended airspace. The Raider is intended to fill the gap, creating a large force of advanced bombers that can strike any target anywhere. The Raider is engineered from the ground up as a dual-capable penetrating strike stealth bomber. The Air Force intends to order no less than 100 airframes, maybe even 200 by production end. Beyond stealth, one of the Raider's more important features is range. In a potential Pacific conflict with China, forward air bases and refueling tankers will be primary targets in China's anti-access area denial or A2AD strategy. The Raider will need intercontinental range while carrying a large payload. The idea is to project power from the mainland US or Australia, acting as a hedge against allied targets within the first and second island chains. Think of the B-21 Raider as the cornerstone of America's nuclear modernization strategy. It will replace legacy Cold War bombers like the B-1 and eventually the B-52. Remember, the B-1 no longer carries nuclear weapons. The Raider will become the backbone of the air-breathing leg of America's nuclear triad while also carrying conventional bombs. So far, we've talked theory and concept. Nothing compares to seeing the real thing take flight, unless you have two of them flying. On September 11, 2025, a second Raider took to the skies from Northrop Grumman's Plant 42 in Palmdale, California, flying to Edwards Air Force Base for more testing. A second airframe allows the Air Force to go beyond basic flight tests into weapons testing and mission readiness. Think of it as two parallel efforts. One aircraft could test aerodynamics, while the other tests sensors and mission profiles. Another interesting note, the second Raider flew in a clean configuration. The first Raider, nicknamed Cerberus, had a data probe and trailing cone deployed. The second Raider has no official nickname, but some call it Spartan based on artwork seen on the jet. This almost can't be understated. The fact the second B-21 flew with no external test gear tells us something huge. The data from the first jet matched so perfectly with the aircraft's digital twin that engineers already trusted its performance. They were confident enough to skip the training wheels. That's a massive win for the B-21's digital design philosophy. And a big reason this program has stayed on time and on budget, almost unheard of in modern military aviation. This isn't just a win for pilots and designers. Having two flying examples also allows maintainers to get hands-on experience, turning around two jets for flight ops and developing maintenance schedules. Northrop is making each Raider as production-ready as possible, so when the assembly line kicks into full gear, all tooling and maintenance procedures are in place from day one. The second Raider moves things from testing an airplane to building a combat system. Now let's talk about the stealth design of the Raider. The B-21 isn't just another stealth bomber. It's what happens when you take the legendary B-2 Spirit and give it 30 years of upgrades in materials, aerodynamics, and manufacturing tech. Thanks to recent photos, we've gotten our best look at the Raider's shape, especially that mysterious aft section. It's a stealth masterpiece in both art and engineering. For years, the rear aspect of the B-21 was a closely guarded secret. At its reveal, they only showed the front, partially pulling it out of the hangar. This wasn't a coincidence. It was a lesson learned from the 1988 reveal of the B-2 at the same facility when a crafty journalist rented a Cessna to fly over the ceremony and get photos showing the world the B-2's exhaust design. Why is exhaust design such a big deal? Hot engine exhaust is one of the biggest sources of IR or infrared emissions. When most people think stealth, they think radar evasion. But one of the more recent ways to detect a stealth aircraft is using infrared search and track or IRST sensors. These sensors are passive, meaning they don't give off emissions and can see an aircraft without radar. They're also small enough to mount on fighters and relatively cheap compared to air defense radar systems. To counter this, the Raider takes a similar but improved approach from the B-2 Spirit. Like the B-2, the B-21 has its engines buried deep within the airframe. The engine's exhaust is ducted through channels before being expelled through flat, slot-like openings. This does several key things. First, it completely shields the hottest parts of the engine, the turbine and combustor, from view, especially from ground-based threats looking up. Second, it spreads the exhaust over a wide, flat area, allowing it to mix with cooler air, lowering its temperature. In the B-2, special materials in the channels cool the gases further. What makes the B-21 different is rather than using a sawtooth trailing edge at the exhaust channel. Like the B-2, the Raider uses an advanced design with advanced materials, using updated geometry and likely airflow mixing. Before the exhaust exit, the Raider manages heat far more efficiently. Imagine advancements in material science and computing power since the 1980s, and you understand how far the Raider has come. But the Raider is more than a flying heatsink. It's designed for all-spectrum low observability, minimizing its signature across the entire electromagnetic spectrum. That includes radar, infrared, acoustic, and even visual detection. That's another huge leap from the B-2, designed mainly to defeat Cold War-era Soviet radar systems. One of the biggest strengths and weaknesses of any stealth aircraft is radar-absorbent materials or RAM coatings. These coatings absorb radar signals, keeping the aircraft low observable. However, they are expensive, wear out from the elements and flight operations, and need reapplying, usually by hand. Fortunately, the B-21 SRAM coatings use next-gen materials designed to be effective against a much wider range of frequencies. From what we've seen, they're also much more durable than the notorious delicate coatings used by the B-2. When it comes to the actual geometry of the B-21's airframe, it's a study in stealth optimization. The engine intakes, a major source of radar reflection, are more flush with the fuselage than the B-2's. The cockpit windows are redesigned, eliminating seams that could create radar hotspots. This new window design keeps the critical frontal radar cross-section as low as possible. Many have noticed the B-21 is smaller than the B-2 and will likely carry a lesser payload. This is intentional. Where the B-2 was designed for a Cold War mission carrying large nuclear gravity bombs, the B-21 is made for a modern era of more precise networked warfare. Today, the Air Force seeks a larger, more survivable fleet over the sheer payload of a single airframe. A smaller aircraft is stealthier, more affordable to build and operate. With a planned 100 airframes, it'll be 5 times larger than the current B-2 fleet. Think of it like this. The B-2 was built in the analog, handcrafted age. The B-21 is being built in the digital age with model-based systems engineering. That brings us to what's under the hood. If the F-35 is a flying supercomputer, the B-21 is a flying data center. Introduced as the world's first 6th-generation aircraft. One core concept of the Raider is its open system architecture, or OSA. Older systems like the B-2 are built on closed hardware and software. From the 1980s, making upgrades slow, expensive, and invasive. B-2 upgrades usually require depot-level modifications. With the B-21's OSA, it works more like a modern smartphone's operating system. The hardware is decoupled from the software, allowing rapid, seamless upgrades through software updates and modular hardware components. You get a near-future-proof jet with new applications, sensors, or weapon systems added with minimal downtime. This is one reason upgrading the F-14 Tomcat was such a huge undertaking. The entire jet was analog hardwired to work with the AWG-9 radar and AIM-54 Phoenix missile in the Raider's case. Because of ease of upgrades and flexibility, the B-21 could flip the script on the bomber's actual role. Traditionally, bombers have been finishers in the kill chain, showing up after intel is gathered and targets identified. With the Raider's extreme stealth, long range, and massive sensor suite, it can fly recon, conduct battle management, serve as a comms node behind enemy lines, and strike targets all in the same mission. Also, while initial B-21s will have a crew of 2 pilots, the Raider was designed from the ground up to be optionally manned. A Raider could fly as a very high-powered, capable drone, staying airborne for days without crew rest. With pilots on board, the Raider could also work as a forward drone controller, coordinating large flights of collaborative combat aircraft, or CCAs, fighter-sized drone swarms neutralizing enemy air defenses or high-value targets while keeping pilots out of the danger zone. What does this all add up to? The Raider isn't just another shiny jet. It's the Air Force's answer to decades of aging bombers, shrinking force size, and a far more dangerous sensor-rich battlefield. We went from B-52s built in the Kennedy era to B-2s and B-1s that are middle-aged or older. That reality shaped everything about how the B-21 was built. Long-range, true low observability, digital engineering, open system upgrades, and the option to fly with or without pilots on board. Put simply, the B-21 is meant to be the bomber fleet the Air Force actually needs for the 21st century. Big enough in numbers to matter, stealthy enough to survive, and flexible enough to keep getting better after it leaves the factory. It's not a replacement for nostalgia. It's a practical tool for deterrence and warfighting in a world that's changed dramatically since the last bomber line shut down. And here's the question you're probably asking yourself. When the B-21 finally retires, how many B-52s will still be flying? Now you know.